Alright, so we've, in the last video, we looked at our function f of x equals 1 over x. It is, remember, a reciprocal function, y equals 1 over x. And then we said, what happens as x grows without bound, either to positive infinity or negative infinity? Well, what we discovered was that as x approaches infinity to the right, as x goes incredibly far to the right or incredibly far to the left, what happens is f of x will approach 0. But it never really touched 0. That is a horizontal asymptote. A horizontal asymptote. In general, a horizontal asymptote is, oops, I'm going to use a better color, is a line that the graph approaches It's going to be a line that the graph approaches, but does not touch. So we are going to get very close to a line, and that's a line of y equals whatever, and that's going to be my horizontal asymptote. So if we look at the picture right here, we can see as x got incredibly negative, as we go negative infinity, we're getting very close to the y-axis, but we never touched the y-axis. As x went incredibly far to the right, as it approached positive infinity, this line got closer and closer and closer to the y-axis, but it would never approach that, because that means the line y equals 0 is my horizontal asymptote. We're getting close to this line, but never touching it. That's what an asymptote is. In general, a definition of an asymptote, we can say if a function is a fraction, a function is a fraction, where it's going to be p of x over q of x, and of course q of x cannot equal 0. If f of x equals b, and b is just going to be some real number, we're going to come up with we're going to plug in some values, and it gives me out a real number. And as x approaches infinity, either positive infinity or negative infinity, we're going to go left or right, because if we put in a negative, we're still going to get out our infinity. Then y equals b is a horizontal asymptote. Which line, which values, as x gets incredibly big, what is the value that b will approach? So as we've attempted to graph this, we have a problem at x equals 0. Let's look at this a little more closely. What's happening as x gets closer and closer and closer to 0? So we're getting closer to 0 this way. We started off at 0 and we got larger, but let's look at it backwards. Let's take a fraction 1/10. If I go 1 over 1/10, 1 divided by 1/10, that's 10. 1 divided by 100, it's 100. I'm not 1 divided by 100th, not 100. 1 divided by 1,000th, 1,000. 1 divided by 10,000ths, that's 10,000. 1 divided by 100,000, 100,000ths. So you can see we're getting these the values of x are getting smaller and smaller and smaller and smaller. But what happens is when they get to be 0, what happens when we try to plug in a 0 in this fraction? Then we are undefined. As soon as you plug in a 0, this whole function is undefined. You can see my f of x values are getting bigger and bigger and bigger and bigger and bigger. The closer x gets to 0, my f of x values are actually increasing. So in our table, what number is x approaching? Well, when we're graphing this, it looks like x is actually going larger. But actually what we're going to say is, if you look at it the way I did them, I started at the larger values and I worked my way down. What we are going to say is x is approaching 0 from the positive side. From the positive side, x is approaching 0. Well, what is happening to our y values as x is approaching 0 from the positive side? What's happening to the value of the function? Well, f of x, or y, is approaching infinity. My fractions of x are going to get smaller, and f of x is going to continue to get larger. Well, did we notice anything about the values of 1 over x as x gets closer and closer to 0? Yeah, in general, what we can say is the values of f of x will increase without bound. They're just going to get larger and larger. They're going to approach infinity. So as x gets closer and closer to 0, like I showed you in the table right here, look, our x is getting smaller and smaller and smaller. And if we put in more spaces between here and 0, these numbers would get larger. They would keep getting larger until we actually decided to get to 0, and then it just doesn't work. So does it appear that 1 over x approaches any specific number as x approaches 0? Well, maybe not a specific number, but again, we're noticing that f of x is going to approach infinity. And can we find a specific value of x? What value can I plug in for x for when 1 over x will be 1 billion? Yeah, and that's going to be 1 over 1 billion, or 1 billionth. One billionth. Don't forget that. Lets everybody know it is a fraction. Alrighty, so we talked about trying to introduce you to the concept of horizontal asymptotes in this video. A horizontal asymptote is a horizontal line that a graph will approach but never cross. So we've got our coordinates. A horizontal asymptote is going to be a line that my graph will approach in some manner but never cross. So we can approach it from the positive side. We can come in like this, and we're going to get really close to that line, but we will never touch that line. And as x is, and same thing if we come this way to the negative infinity, we're going to approach it, but we're going to get super duper close. As the larger the x value gets, the more negative x gets, y will get super close to that line and never touch it. That's what a horizontal asymptote is. So in our next video, we're going to talk about rational functions and some more about those issues. So if you got any questions about horizontal asymptotes, please let me know. I'll be glad to answer them, and we'll see you when we see you.